I
So
tell you what, I think I may offer a few jobs if we get efficiencies like that. That is truly truly incredible, and it's great that you're part of the Engineering Tomorrow now. I think we've got 1.1 million students have gone through this program already, so it is just growing and growing and growing. And a big shout out to Bill Woodburn, our founder, that felt that engineers we need to build more engineers around the globe, and it's going really well. And we've got some support from Port of Melbourne, New South Wales Port, Sydney Airport, and Venus, some of the companies that are actually making sure that the program is essentially free and accessible to all schools around the globe. So pretty exciting. And I got to tell you what, people often ask, if you had your life again, what would you do? And I'd say I want to be an engineer. So it's a fantastic career. Had the ability to travel all around the world, meet lots of people, and the great thing about STEM studies is that the science and math doesn't change depending on which country you're in. That 1 + 1 is always 2. Doesn't matter where you are. The principles of Einstein still hold irrespective of where you are. So it's very transportable. But if you want to stay where close to home, you can do that as well. So it's pretty amazing amazing to do it. And prior to sort of I guess getting on this call, I thought about bridges, and I actually learned something about bridges in Australia, and maybe a pop quiz for folks on the line. Do you know what the longest bridge in Australia is? Any guesses? Where do you think Sydney Harbour Bridge is? Do you think that's the longest bridge in Australia? No, we're shaking your heads. Well, that's right. So if we go to the next page, just if we can flip to the next page. So the longest bridge is actually in New South Wales. It's Macquarie Valley, and it's a bridge that it crosses the river, but there's lots of floodplains in and around that area. So they built the bridge exceptionally long, so when the water level is high or when there is floods, the transport can still go across that bridge. So I'd never even heard of the bridge, but 3.2 kilometres. Then South Australia comes in second, the South Road Superway Bridge, a fairly new bridge, 2.8 kilometres. And then Queensland Port and Highway Bridge is 2.7. And the West Gate, which I guess all the folks in Victoria will remember that bridge fondly. And it's quite interesting. You see, anyone that's gone across the West Gate Bridge, you see the big, I guess, pillars and cables. That's actually not required to support the bridge, funnily enough. So from an engineering point of view, but it was put there for, I guess, more of a, to ensure that the public felt comfortable with that bridge, given it had some issues in the construction. So if we go to the next page, Queensland St Leo Heinz Bridge, quite a nice bridge, a new bridge, 1.6 kilometres. Sydney Harbour Bridge is only 1.1, so it's not, doesn't even make the top 5. And very similar to the Westgate Bridge, you'd see the big, I guess, limestone or sandstone pillars at either end of the bridge. They're not actually there to support the bridge. It's actually the steel structure and the arc that is actually the structure of the bridge. So when you see the big pieces at the end, they just make it look beautiful. They're not actually for the structure of the bridge. And then Tasmania come in at 7 with the Bowen Bridge. So many different sort of designs from using steel, composites, concrete. So there's many different ways to construct bridges and many things that you need to consider. But I guess with bridges, it's great to see the bridges that we drive across, and we probably take it a little bit for granted. But engineers sort of learn as we go along, and we actually learn from some of the mistakes that we make, which is super important in the learning. So if we go to the next page. So around the world, there's been quite a few bridge failures, and there's many different causes to the failures. And whenever there's a bridge that fails, usually there's communication that gets sent out to engineers that work in this field so they can learn from what actually happened. And some of the bridges fail because there's floods or natural disasters, earthquakes, etc., which are a little bit hard to plan for. But if you think about bridges that are in Japan, for example, where there's lots of earthquakes, the design is a little bit different. But it could be from collisions. There's a bridge that fell down in Tasmania when a ship struck it. But I think there can be other sort of things with poor design, structural issues, construction techniques. There's many reasons as to why bridges fail, and it was interesting to see the weight on the bridges in all the classrooms that as to how much weight they could actually carry, and it's sort of based on the design. But as Joanne would have, I guess, explained with you, is that the cost of the construction is really, really important as well. So you don't gold plate bridges and overdo it based on what the specifications are. So really important to share, I guess, the learnings from failures. And I guess when you talk about failures, it's really about learning and making sure that you can change the designs, and engineers continue to grow through their education. So I guess we've spoken about the bridges in Australia, and I thought the longest one was about 3 kilometers. I guess with engineers, we push the boundaries all the time. So this is the longest bridge in the world. It's actually in China, the Dangyang Kunshan Grand Bridge, which actually joins. It's a little bit. It's actually part of the transportation belt between Shandong Province to Beijing, but 164 kilometers long. So it would have cost a lot of money, but this is what sort of when you think about being an engineer, it continues to grow and grow and grow as to what we can potentially do. And as we develop our materials, we can actually do some pretty incredible things. So I lived in China for quite some time doing engineering, but I've never been on this bridge. It is just fascinating to see it and see how long it is. So, if you use your creativity and your innovation, you can do some pretty amazing things. And if you think about everything in daily sort of life, if you think about sort of, I started in mining coal, which actually made steel. I worked in steel works to make the steel. The steel went into building cars. I worked in the automotive industry there for a little while, building cars and building tires for cars. And then I guess the GIP field, we have renewable technologies as well. So one of the labs is actually building solar powered cars. So it's pretty cool. So the breadth of engineering is quite expansive as to which field you're in, and I'm probably a little bit more in the banking field. So I went from coal mining to banking, so it's pretty cool. So if we go to the next page, so that's bridges. Any questions on the bridges before I move on?
Well, I think that's amazing. I feel like 164 kilometer bridge is pretty. You can't. It's mind boggling. I know in the Florida Keys there is a really long bridge similar in design, but nowhere near 164 kilometers long. But it takes you uh, off of the mainland of Florida and down into the barrier islands around there. So, are you familiar with the location of this bridge from your time in China?
Yeah, so certainly Dangyang to Kushan. I've been in Kushan before in a petrochemical operation, visiting it to build a part of a supply chain when I worked for SABIC. And Dangyang is, I'm aware of where it is, but I've never actually visited there. So it's actually a high-speed train that travels across this bridge as well, which is just astonishing.
Yeah, that might be a little scary to think about. Well, thank you so much, Mark. I have a few questions for you. If and I want to encourage students to ask questions as well. Feel free to unmute or add some questions to the chat. I know my friend Constance is monitoring the chat for me as well. But let's start with one. You started to talk about a lot of the different roles that you've had Is there a role that has been a standout for you, one that's been particularly rewarding?
Yeah, I think it's a good question because there's lots of really amazing things and amazing opportunities you have as an engineer or in science when you actually study. I think um, probably one of the most exciting sort of roles was when I was working in the Middle East, and we actually had to build a port and a railway line and some roads for trucks to actually export product out of Saudi Arabia. So it's pretty amazing when you've just got, I guess, plains and kilometers of sand, and you need to build a port, and you need to make sure the water is deep enough to receive some of the biggest ships in the world. So I think that role was pretty exciting, starting from, I guess, a blank sheet of paper and working through it and bringing experts in from all around the world to work on the port. So that was pretty amazing. And we built a railway line across the desert as well, which was pretty exciting as well. There was I guess there's still transport that's been done by camels in Saudi Arabia, and we put a train line through there. So we had to build 90 bridges so the camels could actually traverse the train line, which was something we hadn't had in the plan. We didn't realize camels were quite important for the trade in Saudi Arabia. So that was pretty amazing. So sometimes when you do projects, you get surprises or challenges you hadn't thought about. I didn't think that we needed to build bridges for camels, but surely enough, the King of Saudi Arabia said that it was important that we did that. So that was probably a really fascinating role.
Yeah, it sounds like it. And I guess you've had a lot of different roles in your career. Was there a reason you chose mechanical engineering to start with? And then maybe a follow-up on that, you then went on to get advanced degrees. What what was your incentive in the way you approach getting
Yeah.
your
So,
schooling?
so
Why mechanical engineering, and then why the follow-on degrees?
yeah, so mechanical engineering was pretty. I grew up on a farm, so fixing tractors and trucks and motorbikes and all those sort of things, and just tinkering with them. And my grandfather had an engineering workshop where he did a lot of mechanical work, building conveyors, and he taught me how to rebuild engines and things like that. So mechanical was something I sort of fell into just because of the environment. And then sort of as you become a mechanical engineer, one of the things is you always wanted to build something really impressive. And then it's sort of a case of, well, you've got to be conscious of the cost of actually building things. So then it was really important to understand, I guess, the financial aspects around engineering. That's why I did an MBA. And then as I was sort of working through building supply chains in Asia Pacific, moving, obviously China's grown quite a lot since I was there, but you know, I guess linking all the modes and all the transports together. So supply chain was super important, and receiving, you know, millions or trillions of tons of product into Asia. So that's why I studied supply chain. It was really um, I guess, an important area that we're working upon. And I think we're sort of now appreciate or take for granted global trade. That can't happen without supply chain. Um, and then as I guess people started to understand about the warming of the planet and environmental type considerations and reusing products. In fact, in the carpet industry, they reuse fishing nets from Asia that are discarded. They actually weave it into carpet. So the sustainability piece became super important. And knowing that from a carbon point of view, you know, there is it's not a plentiful supply. So it's really a little bit around being socially responsible as we work through, as a lot of companies are, you know, being more focused on that area. So it really just sort of followed the trends and followed the roles that I did as to why I did more and more study.
Pretty
And
impressive that did you do this while you were working full time as well?
yeah, so my first engineering degree was full time. All the rest was late nights, early mornings. And I think it's I guess a tip for all the folks that are actually in the classrooms building their bridges. It's much easier to learn when you're young. The older you get, it becomes more and more difficult. I speak Mandarin, but I'm not as fluent as my son is, who reads and writes it. So it makes sure that you always continue to learn, particularly in the early stages of your life and your career.
Great advice. Well, and also sort of thinking about how you structured your day. You worked on this variety of projects, you've worked in different countries. What is a typical day like in your work now? What's a typical day in
Yeah.
the life of Mark?
Yeah, so I'm working quite heavily on Sydney Airport at the moment. So we've got a few major redevelopment projects with particularly international terminal, but also the domestic terminals we're working through to try and make it a better customer experience. So for me, I'm an early riser. I'm usually up at 5:30 or 6 a.m. I'll go to the gym. Working in I guess, a global environment, and engineering is a little bit sort of global. So I check all the emails that have come in overnight from the US and the UK to make sure I'm up to speed on things within the company and work out as to whether I need to respond. And then it's sort of into a range of different meetings of designing new parts of the airport and just making sure that the airport is running as well as what it should be. I usually go for a walk through the airport. I've got a nice little badge that allows me to go anywhere I need to. So I can go sort of through immigration, through customs, and just check to see that the passengers are flying through the airport. And when you wear a badge, you get asked lots of different questions about the airport. So you need to know where everything is. Usually at the end of the day, summarize on any actions, work out what needs to occur in the next sort of 7 days forward. Make sure your travel plans are all arranged. So I'm based in Melbourne, so I fly quite a lot to Sydney, and I'll be in New York in a few weeks' time. So that's sort of pretty much a typical day. And then when I am traveling, I ring the family. My wife, I've got two children. One's 20, probably he doesn't like to be called a child anymore, and a 16-year-old. So I usually give them a call and see how their day went and encourage them to continue to work very hard in school and be the best version of what you possibly can be. So that's a fairly typical day.
Yeah, and we talked early on today about stakeholders, and it sounds like even as you walk through an airport, you're connecting with multiple stakeholders in the improvement of the airport. I imagine you're working with a lot of different types of professionals and the public.
Yeah, definitely. So there's about 60 different airlines that travel through the airport. So yesterday, for example, we met with Cathay Pacific to talk about biometrics and technology control and automation for check-in and customs and also inbound. So a few weeks, like last week, it was Air New Zealand. We're talking with Qantas at the moment. We speak with the government quite frequently because they control the immigration components of the airport. Within Sydney, we have we have a finance team, we have a commercial team, we have a retail team. So working through with all those groups to try and drive those synergies to make the company operate more smoothly, and lots of different passengers. And one of the things we're working very hard on is passengers that have some disabilities, as to allow them to be able to travel just as well as anybody else. So we're working through that. And in Sydney Airport, we've got a new airport that's getting built, which will be one of our competitors. So we're keeping a close eye on as to where they're at and who's having discussions with them. So there's lots and lots of different stakeholders, and just like human beings, we're all a little bit different. We all have different hot buttons and different styles. So it's navigating that environment, which is it's an area of grey, which is always keeps it exciting.
Well, you've certainly held a variety of roles and done a lot of different things. It sounds like it's been a really exciting ride so far. Do you have any advice you think you would like to share with our students today? Some top tips?
Yeah, so I think obviously, keep learning. Test your boundaries. I think it's really important as you work through STEM. I think it's yeah, sort of fairly important to continue to sort of think about innovations. Um, I think it's very important that don't surround you with to surround yourself with people that are just like you. You need the diversity. You need different thoughts from different people, even though some people make some suggestions that you think are a little bit silly. It's really to really keep an open mind, and you'll grow yourself, and you'll actually get a better outcome. So um, I think one of the things in all organizations I work for, everyone brings value into the business and into their sort of lives. So if you get bogged down in a really difficult problem or a difficult subject or a difficult question in maths or science, you don't ever think you're alone. Reach out and ask for some help. And think about the bridges that I spoke about that had failed. Those people reached out for help as to why did this go wrong? Please come and help me explain it. And you've also got a responsibility to help others as well. It's a two-way street as you go through. I think engineering is a little bit about solving problems, whether you're developing new materials so you can do something pretty special. If you think about landing on the moon or the space station, um, initially we didn't know how to do that. So a lot of engineers got together and they solved all the problems associated with getting people onto different planets. If you think about Elon Musk, um, interesting personality. I spoke about sort of people that have different sort of views and approaches. But if you think about the electric car or creating a private space company, I mean, that was radical, and everyone said there's no way you can make that profitable. But he has, he innovated and solved problems. And the world does change, and I guess I walk through why I'd studied different things. The world does change. So really embrace that change, understand what opportunities that change actually brings to you. And the last thing is that you got to have fun. The jobs I've sort of done, some parts of it I maybe don't like so much, but by and large, I come to work every day and I actually have fun. I can't say when I went through high school at your age that I thought it was a lot of fun, but if you stick at it, you get a good job, and then you'll have a hell of a lot of fun as you go through. So they're probably some of my top tips as you charter your journey through your life. And for me, engineering was most definitely a really exciting career. And I may be nearing retirement, probably got another decade, but you're just about to embrace and start on your journey. So own your journey, and I guess some of my top tips. And it's great that you've joined
Got
in.
him there. Yeah, thank you. Thank you so much. I feel like you've left us with some really good advice, and I'm presenting. I tried to take some quick notes and jot down your ideas, but definitely I fully agree with you about keep learning. It's fun to keep learning. You always are acquiring new skills, and it's do things that are fun, but also challenge you, test your boundaries. I love that.
Yeah.
Um, None of this happens without a diverse group of people. So I loved your advice to listen to others. Everyone's ideas matter. Um, Ask questions, prepare to be a problem solver, embrace change, and most importantly, have fun. I think those are all such important just life tips to keep in mind. So I want to thank you so much. We have a few, I just wanted to share kind of a few um, slide pictures from our time. I know we are running very short of time, but we had so much fun.
Oh,
Constance caught me in full smile there. So, but I wanna give shout outs to all the high schools: Canterbury, St. Aloysius, Lewisham, Heathcote High School, Ashfield Boys. Thank you for those great designs. Marist College, Kogarah, Gymnea Technology, and St. Vincent's Ashfield. I feel like it was St. Vincent's or Ashfield that got the highest weight on a bridge, but I know we still have more to test. So with that, I'm going to stop sharing. I'm going to turn it back over to Vicky. Let's all give Mr. Tarrant one more big round of applause. Thank you so much for your time.
thank you.
And thank you so much to the engineers who were in classrooms. I felt like you really helped to make it such a fun event. And Vicky, the floor is yours.
Thank you. Thank you very much, Joanna. Well, just to close out from me, really to thank you to everyone. What an energising session that was. Special thank you, obviously, to Joanna and Mark. What an opportunity, and how fortunate are we to have exposure to your expertise, your advice, your guidance. Just an opportunity for the students to hear, I guess, real life engineers in real life environments and where a career in engineering could lead you. So thank you. Thanks also to our wonderful engineers, Mike, David and Sam, for attending some of the schools in person. How fortunate for those students to have a real life engineer walking the ground, helping them build their bridges and do that on the spot learning. Thanks also to Annika and Constance, but a special call out really for the teaching teams in the schools. Special thanks all the students for bringing all of yourselves to the session, opening up your ideas and minds to the possibilities of building bridges, but bringing that fun element as well. So we hope you've enjoyed the session. We also hope that it sparks some form of interest in any of the realms of engineering. And it's, I guess, broadened your awareness of what opportunities could be out there. So we, the engineering team, Engineering Tomorrow team, we've scheduled sessions later in the calendar year. In term 3, we'll be delivering the electric vehicle session. So we strongly encourage you to speak to your teachers, get them to sign up, join us again next term. But more broadly, students, speak with your networks, talk with your career coordinator, your STEM teachers, your family and friend networks, explore all of the opportunities of engineering and really what has piqued your interest. So maybe have a walk away from the session and think about which element of the session has really piqued an interest for you. And while it's fresh, go chat to all of those networks, get as much info you can, and explore opportunities in engineering in the future. So thank you again for coming along, having fun, connecting with your school, and we hope to see you next time.
Okay, awesome. Thank you.